Chapter P.1, Modeling the Real World. In this section, and whenever you're working with real-world problems, you want to refer to the general principles of problem-solving guide to help you with the real-world problems. And this is a guide that you could follow. And some problems you may need to be more detailed with following this, and some problems you can probably do without really hardly looking at this at all. But first, you want to understand the problem. You want to ask yourself some questions. What are the unknown, the quantities, and conditions? Draw a diagram and identify given and required quantities on the diagram, and introduce some suitable notation, such as variables for general use or specific use. Think of a plan. Try to find a connection between the given information and the unknown that enables you to calculate the unknown, and use any of the following. Try to recognize something familiar. Try to recognize patterns. Try to relate to another similar problem. Try introducing something new, something extra. Split the problem into several cases. Maybe work backward. Once you figure out a plan, carry out the plan. Check each stage of the plan to confirm that the process is correct. Once you get a solution, you want to look back and see if the solution makes sense. Try to figure out if there was an easier way to solve the problem. And maybe most importantly, what can you take away from working through the problem that will help you with other problems? So let's look at this problem where we are given a model and a formula. This is example number 3 from page 5. We have a mountain climber who uses the model T equals negative 10H plus 20 to estimate the temperature T in degrees Celsius at elevation H in kilometers. We need to make a table that gives the temperature for each 1 kilometer change in elevation from elevation 0 to an elevation of 5 kilometers. I need to write a 5 in there. How does the temperature change as the elevation increases? So I have this table set up. I'm going to put in 0 to start with 0, and I'm just going to increase by 1. So 0, 1, 2, 3, 4, and 5. And I need to find my temperature for each of these elevations. So I'm just going to plug in my elevation for H into the formula to find the temperature. So negative 10 times 0 plus 20, that's 0 plus 20, so I get 20 degrees. When I plug in 1, I get negative 10 times 1 plus 20, that's negative 10 plus 20, which is 10 degrees. Negative 10 times 0 plus 20 is 0 plus 20. Never mind, I already did 0, so 10 times 2. So that's negative 20 plus 20. My answer is 0. And once I get 3 answers here, I can start looking for patterns. I can see that I'm decreasing by 10 each time. So using the pattern, I can fill out the rest of the table without doing any extra work off to the side. How does the temperature change as the elevation increases? Well, as the elevation increases, the temperature decreases by 10 degrees for each 1 kilometer in elevation. So temperature decreases by 10 degrees Celsius for every increase of 1 kilometer in elevation. Part B says if the temperature is 5 degrees Celsius, what is the elevation? I don't have 5 degrees temperature. I do have 0 and 10, and obviously 5 is in the middle, so I'm probably going to get 1.5. So let's check. I plug in 5 for T, so 5 equals negative 10 H plus 20, and I'm going to solve this for H. So subtract the 20. I get negative 15 equals negative 10 H. Divide by the negative 10. That gives me H. And divide negative 15 divided by negative 10, I will get 1.5. So 1.5 kilometers. Make sure you label the units. Looking at writing an algebraic model. Here an example says write an algebraic formula for the given quantity. The product of two consecutive integers. The first integer is n. There's a couple, I underlined these terminology because we need to know what these mean to be able to work through this problem. Product is the answer of a multiplication problem. Consecutive integers are numbers in order increasing by 1. For example, 3, 4, 5, 6, 7, etc. Those are consecutive integers. They are increasing by 1. So if our first integer is n, our second integer, you increase by 1, you show that by writing n plus 1. So we have our two integers. Now we have to find the product. So we multiply them together. N times n plus 1. With this, I could distribute the n and get n squared plus n. And there's my algebraic formula. I could say P equals for product equals. Here's an example where I need to represent the area of the design shown. When I look at this, I need to realize that I've got semicircles on the outside of a square. 4 semicircles gives you 2 circles, and we have 1 square. So I'm going to take the area of 2 circles and add it to the area of a square. Well, the area of a circle with a radius of r is pi r squared. Circle again with a radius of r, pi r squared. What are the sides of the square? Let's look. Well, half the distance is r, so that means the full distance would be twice the value, twice r, so 2r. So therefore, a square is base times height, which is 2r times 2r. So we've got pi r squared plus pi r squared, that is 2 pi r squared, plus 2r times 2r, which is 4r squared. And that's our formula for area of this design. Yeah, if you try to add these together, you run into the problem of how do you calculate 2 pi times 4 without rounding. So you could say 3.14, and if you do that, then you come up with 10.28 times r squared, but we usually want to leave pi as a exact value, so this would just stay as is. Okay, here we've got a problem where we've actually got to work some things out and get solutions and write a formula, okay? So at a certain rental agency, a compact car rents for $82 a day and 15 cents a mile. Part A says, how much does it cost to rent a car for 4 days if it is driven 245 miles? In your notes, I originally put 240 and I wanted to change it to 245, and I apparently forgot to change that. If I did not change that by hand on your notes, make sure you change that. So if we have $82 a day and we're talking about 4 days, we're going to take those values, 82 times the 4. And when we multiply 82 times 4, we get 328. And then 245 miles for 15 cents per mile, we're going to take 15 cents. That's got to be a decimal, just like you would see it with written in money terms. 15 cents per mile times the 245. When we multiply that, we get 36.75. So our total cost is going to be adding these two things together. So when you add 328 plus the 36.75, you will get 364.75. Now part B says find a formula that models the cost C of renting this car for N days if it is driven M miles. So our cost is what we ended up with. So cost is equal to, for renting this car N days, we took $82 times the number of days, in this case N, so 82N, and we added that to 15 cents, 0.15, times the number of miles, in this case we have M. I don't really need the parentheses there, but it's okay. There's our formula for cost. And finally, part C says if the cost for a 4-day rental was $380.50, how many miles was it driven? So we're looking for miles. We have our N of 4 days going off of this model, and we have our C. So let's plug in everything. We get 380.50 equals 82 times 4 plus 0.15 times M. 82 times 4 is 328. And we're going to subtract the 328. That cancels. We are left with 52.50, 52 and 50, $52. And we over here, we have the 0.15 or 15 hundredths. We're going to divide by the 15 hundredths. We cross that out. We get N is equal to, when we divide this, we're going to get 350, which means, oops, that's M, and which means 350 miles. Again, make sure you label. And that's it.